Hey, Dustin Vanoy here. Thanks for joining me for another video of Apache Spark Data Kickstart. In this video, I'll cover some of the basics of Python and how we write Apache Spark applications using Python, which is known as PySpark. So I'll talk through a few key points, which will apply to Spark regardless of the language you choose. But I do also plan to make some videos focused on SQL for sure, and probably Scala down the road. So check the description where I'll update with links for other versions of this tutorial, or find the appropriate playlists, as I'll probably break those up by playlist. Okay, so to get us started, let's pull up a Spark environment and run some very basic Python commands. After that, we'll jump into the PySpark commands all within the same video. I'm going to use Databricks Notebook using Databricks Community Edition, which I showed how to get set up and running with if you don't have a Spark environment. You can follow along with other Spark environments if you like. I'll make a few comments at the end about where to get the data and how to do it differently if you're not running within the Databricks Notebook. So here we go. Let's walk through the Python Kickstart first. Okay, so here I am in Databricks Community Edition, and I created a new cluster. Right now what I've been seeing is that I can't spin up an old cluster, and I have to create a new one each time. It doesn't bother me. I can work with that for a free environment to do this training. If you have a different environment, though, that's completely fine. So the first thing I want to do is talk about some Python basics. And so when we're in Databricks or any type of Spark environment that supports PySpark, which most of them will, we can run standard Python commands as well. It's not going to distribute across a cluster of machines and take advantage of the Spark syntax, but for usually the setup part of the code, you end up using some pretty traditional Python syntax, and then you work in the Spark commands as you go. So let's start with some important concepts for Python. This isn't meant to teach you everything you need to know, but I think it is going to give you enough that as I go through different Spark examples and how we do it with PySpark, you'll be able to pick up on what's going on without too much stopping and reiterating what the different objects are. If you want to really dig into Python and you haven't before, I've got a link at the top of this notebook that goes to a bunch of different resources, a bunch of them free that you can use. I've done a little bit of vetting of each of these and it looked pretty good to me. Hopefully they're all still out there for you by the time you see this video. Okay, so the first thing I want to do is zoom in just a little bit here so we can take one piece at a time. Let's talk about strings in Python. So to run our notebook, we can either hit the play button, run cells in our notebook, we can either hit the play button or do like a control enter, command enter, those types of things. When you do that and it hasn't already attached to a cluster, it'll give you a little prompt like what you just saw. Okay, so as it's getting that session created and running this first code, what we are doing with strings is we are creating variables called myvar1, myvar2, and saying myvar1 equals, and then with either single quotes or double quotes, we can create some type of string input. So a lot of the data you work with, a lot of the tables you work with are going to include some amount of strings, but we do have more advanced data types we can use both in Spark and within Python itself. Okay. Note that on line 4, we can print things. You can print one item at a time, or you can use comma-separated variables or strings that you type in directly to do prints. So now we can see that our string1 variable and our string2 variable are set. Notice that we do not have to set the type. It will determine the type based on what you give it. If I were to go through and take myvar2 and set it to a different data type, it will switch data types automatically for me. Some people aren't as comfortable with this because they've programmed in other languages. You can use type hints to help you know what's going on, but you really don't have to. And I'd encourage you to start this way. As we get to building up some functions and things in the future, we'll probably do some type hints so that you see how that goes. Okay, one other thing we want to do, well, I want to do, you don't need to on your end, is I'm going to clear the state and the outputs so that we can have a fresh session here. Okay, so now that I cleared the state, I can rerun, and you can see it still has a context. It runs pretty quick there. Now, continuing on with strings in command 4 here, we've got a concatenation of strings. And so the most simple way, probably the most natural way for programmers to concatenate strings is on line 1, where I set a variable equal to variable 1 plus some string I just make up on the fly plus another variable, and any combination of strings you're defining directly in variables will work here. If I'm trying to add in like an integer, I usually need to cast that to a string specifically, which can be done doing something like this here. So you may see that from time to time where we cast a value to a string in order to concatenate. We also have a formatted string. I use these a lot. I may not use them initially, but I use these a lot to substitute in variable values. So I've got this string, my variables are, and within the string itself, within my quotes, I define these curly braces and a variable name to define what I want to inject there when I print it. So now when I print each of these strings on their own line, we'll see the first item is concatenated string 1 and 2. And the second one has replaced those curly brace values with the actual value within the variable. Hopefully that makes sense. That F in front of it is how we know we're working with formatted strings in Python. It's something like Python 3.6 or 3.7 is when this came into play. I do recommend you try to use a version at least at 3.7 or above when you're working with PySpark. Okay, let's look at some other data types then. So this is a few important data types. We have on line 2, we have integer myInt equals 12. You can see that I don't have to specify the type because it can tell that this is an integer based on the fact that it's a small number that is a whole number, or a round number, really, rounded number. When I go to cost, I can get that, and that'll automatically assume a float. And so because there's decimal points, it gets treated as a float in Python. And then for Boolean, I can set these as true or false, capital T, capital F. There's a few other things that will get interpreted to Booleans appropriately. So when I print each of these with their type, I can see that I've got an int, a float, and a bool, just like I said, and I can see those values next to it. Okay, so you'll see a lot of ints and floats. You won't have to think too hard about it a lot of times, at least not to get started. Boolean's kind of important to know about because trying to do conditional statements, which we'll get to, I'm sure, before long. Boolean is one way to work with those. Another is that it will interpret any like positive values as true, any values that are not empty or false. Okay, so let's look at a few more examples here. We have bytes. You can take something like a string and convert it to bytes just by doing the B in front of the string. Tuple is a combination of items that's kind of defined as one object. And so I've got these positional items, different data types. I've got a name, let's say an age, and some kind of Boolean true false type of value. And those are all together in a tuple. And so you may see tuples get used to easily pass kind of combined information as a single object and unpack it from there. Now a set, I don't use these all that often, but some important things to know if you do end up with a set is that it's going to deduplicate for you and it's not going to necessarily keep the same order. So when I run this, we can see we've got the data types I mentioned and that our set has reordered it and removed any duplicate values here. Okay, so bytes, tuple, set, we may not even look at in this course, but I just want to call those out because they tend to come up at some point along your journey, and it's good to know that they exist. Okay, so we talked about strings. Int, float, and Boolean will be very popular. These are less popular, but you may end up using them from time to time. Now we're getting to what I think is probably the most popular, most useful piece of Python code to understand when you're going to do PySpark development. So if we look at a list object, a list is like an array object or like a linked list object in other languages. Line number 1, we can see we can use square brackets and pass a list of values. In this case, a list of strings that represent different names. We pass those in, and then we can also, on line 3, show that you can do a 2-dimensional list. You could do a 3-dimensional list. You can go on and on there. And so in that case, I've got square brackets on the outside here. And then each item is a list in itself. Okay, so I've got like a name and an age that I would end up looping through. I mentioned tuples earlier. These could also be tuples instead if I were to switch these to parentheses. But we'll just do lists for now and you'll see how that works. Another little thing we're showing here is that you would use the none value to indicate a null value. And so you may see none pop up. A lot of times in conditions, you'll have to check for none, but sometimes you'll define it directly the way I did here to say that I do not have an age. When I print these two lists, you can kind of see that I modified something. Okay, when I print these two lists, we can see that they look about how they look in the UI. So nothing too special to see from printing them, but when I come down and I loop through the values, we'll start to get a better feel of one of the ways we'll work with lists. In Command 11, I can do for variable name that I just made up on the fly. So for name in some type of iterable object. So in this case, I'm using a list. I'm going to go through each item and do whatever's under here. I can do multiple things. I can print two things. I could do some calculations. Within this indented block within Python, that's how it knows that this is all part of my for loop, is based on the indentation. This can be a little confusing when you first get started, but it makes for very readable code. So it's something I think you'll grow to love if you're new to Python. You'll certainly figure out how to do it soon, or else you will bail on Python and try one of the other languages we can use with Apache Spark. Okay, so see how it printed each item. Each one's printed in its own block, and that's kind of a simple loop. Now, still not too complicated, but I can do loop through both levels, right? So remember I had each item was its own list. I can say for row, another made up variable name on the fly, for row in my two-dimensional list. Then go ahead and unpack the next set by doing a for loop over each list in itself. So if you remember, we had a list of names and ages. So if I go through and print this, I'm going to see it print the name, then the age, and then move on to the next piece, right? So the first row represents these two lines here. Once it got that row, it went into each item and printed them on their own. Okay, so that's a nested for loop. There's some other things called list comprehensions that are quite helpful, and you may see them eventually. I'm going to try to avoid those for you in this course until we get a little further along. Let's take a look at a dictionary here. So this type is also very common. One of the ways I tend to use this is to represent JSON data, and that tends to get a lot more complex in the example I'm showing. But essentially, it's a hash map. It is a key value lookup that can be used for configurations. It can be used to store a lot of really interesting data. When I reference that data, I don't necessarily need to loop through it like I did with the list. Instead, I can actually use the key itself to get the data. So I set up a dictionary called data, and then I call data key. And by calling data key 3, I'm going to get the value that's there, which is Diana. Okay. And then I could call key 5. I could call any of these. I can also set the value again by doing something like data key 3 equals Bob. And then if I were to print, that, we end up with a name change here. Okay. All right. The other thing I can do that tends to be needed from time to time is I can loop through that dictionary. And often when I'm doing that, I want to loop through both the key and the values. And so that's where dictionary name data dot items. Items is a method on that dictionary object. That's going to return 2 values per basically row in the dictionary. And then with that, I'm just going to print each of those with an arrow in between them. And that's how we can loop through and print out the items in a dictionary. All right, that's what I want you to know about Python before we get deeper. Remember the indentation thing. Maybe I'll make a mistake and you'll get to see what happens if you indent incorrectly. Perhaps I can do that right now. Let's take a look. It's actually going to kind of warn me ahead of time that my indentation's weird. This is the error you get. This is the error I saw over and over and over again the first weekend I ever tried Python quite a few years back. Indentation error. You have an unindent. You have something that doesn't match an indentation level that makes any sense. So I can go one more space to line up with the other print, and it's part of the for loop. Or I could go all the way back to line up with the for loop, and that's going to be valid as well. And in that case, it's going to print everything first, leave the for loop, and then print the last item that I chose. Okay, so that's your indentation error that you might see if you're new to Python. Okay, cool. That's our start with Python. Remember that you have a link to a much more deeper dive on Python if you want. Let's get right into some PySpark now, which is probably why you're here in the first place. Okay, let's take a look at the PySpark notebook now. The first thing I want you to know is that we are going to use the New York taxi trip data in order to build out this example. If you've seen some of my prior videos, I tend to use this one a lot. Here's the reason. you can go and download this if you aren't following along within Databricks or within Azure Synapse, which both have pretty easy ways to connect to this data. So if you need to go download it, you would go to NYC.gov website and find TLC and download the right section from here. For instance, I think I'm using January yellow taxi trip records, and then I'll be using one of the lookup tables down under taxi zone lookup table. Okay, so you can go get those yourself if you need. After I walk through this notebook, I'll show you a way to use bash commands to go download these as well. Okay, so to get to the core of why we're here, the first thing we need to know about using Spark is that we have this thing called a Spark session. So what is this Spark session though? Let's talk about that for a moment. Okay, so if you're using a notebook like I am, or running the PySpark REPL, you'll already have a variable called Spark. That variable is your Spark session. The Spark session, it's the entry point for using all of these Spark features. It's actually a combination of some different types of Spark contexts, which were used directly in older versions prior to Spark 2.0. But we don't worry too much about all that right now. Mostly what you need to know is that you will use this basic Spark session to access the different features of Spark when you're doing API calls, okay? So in this example, we use a very basic Spark session and keep on going, and the options you have to configure the Spark session will come up as we go along this course, where there's many examples of how to set up specific Spark configurations when you're first defining that Spark session. Okay, back to the code. Okay, so we have our Spark session already available. We're going to create a variable called trip input df. I'll explain the df in a moment. We call our Spark session.read. We're able to wrap lines because I've got parentheses set up here. And so spark.read.format, and our format's going to be CSV, which stands for comma separated value. If you've worked with data, you're probably familiar with that. It's assuming that there's commas that define each column in the row. So every time there's a comma, it's a new column within that row. All right, and then we can define whether or not there's headers. And so we have an option called header, and I've set it to true because this data will have headers with it. Finally, to define where we're getting that data from and basically say we've defined everything there is to know about the read statement, we call .load. From here, you can actually, if you're in Databricks, you can use this path that I've got here. It's been working this way for a while. It should for a long time more. These data sets are included with any Databricks environment you get, and you can make this command call, and it's going to go and read a single month's worth of data in CSV format, and the .gz means that it's gzipped, which is a type of compression. Spark is set up to where it's going to automatically understand the gzipped aspect of it and work with that data. Okay, so this defines it. I mentioned in the introduction to Spark video I did that this is lazy evaluating. So it wouldn't actually process any of the data yet typically, except I'm going to call my variable name.show so we can see a little bit of this data. Okay, there we go. We can see the show is not the prettiest way to look at it, but it's certainly effective. We can see quite a few column names, so many it wraps the next line, and we can get a glimpse of our data. If you're in the Databricks environment, you have this benefit of being able to run display and then put your object, if it's a Spark data frame like this one is in there, call display, and it's going to be a bit easier to scroll and browse through the data, right? A little bit prettier. If you're in Azure Synapse Spark environment, you can also call display, and it'll have a similar type of output. Other managed Spark environments, you'll have to test it and see. Okay, so what we have here, this kind of gives us a bit more of a inside view into what's going on. That variable I set, trip input df, is a data frame. So let's talk real briefly about what a data frame is in Spark. A data frame is an object in Spark that is a distributed collection of data. It has rows and named columns, so we can think of it similar to like an in-memory data table. If you've used R or if you've used Pandas, you probably have a good idea already of what working with the data frame is like. If you haven't, it's okay. Just know that it can handle more complex types and nesting than a typical table will in a database. And it has built-in methods that we're going to use for our Spark programming. So it's possible you've heard before of this Spark object called an RDD, which stands for a Resilient Distributed Data Set. Again, if you haven't heard of it, it's okay. The only thing I want you to really think about or know about that right now is that an RDD is a core collection of data within Spark that's being used under the covers as we continue to work with these data frames. I recommend you don't worry, don't do a lot of research on RDDs right now. As we get started, we can work with data frames. Just know that it's being used under the covers, and you'll see it as you start to look into the Spark plans and things like that. We can do a lot with data frames without even thinking about RDDs. But if you stick with Apache Spark in time, you'll probably come to a point where you need to go down and reference the RDD directly to do some more advanced processing on the data. Okay, so data frame is the object we'll be using for this course. If you're working in Scala, there's some additional similar concepts of a data set that you can work with, which just has some more class typing capabilities that are a bit different than working with the data frame, where you have named columns and each column has a data type associated with it. Okay, back to the code. So to recap, we have trip input df right here. I would like to go and do one little thing on that data frame before we move on. So here we have trip input df. What I can do is really quite a few things. And if I hit the tab, it'll start to show me all of the different methods that are available off of the data frame. I typically don't scroll through this list and guess at what it's going to do. I actually go to the Spark documentation, look up the data frame object and look at the methods there. And I believe the page you usually get to is pretty searchable, so you can go look for something that sounds like what you would expect. In this case, probably the things that are really important to know is that we have this with column and with column renamed that let us add or replace columns. With column renamed, you could probably guess is going to replace a column. So let's replace a column. Let's see. I believe I have one called, well, I use all those columns. Let's go find a column I'm not about to use. Passenger count. We can replace, no, store and forward flag. I have no need to do that. And I don't like that long name. So I take store and forward flag and I change it to store forward flag. Sure. Why am I doing this? Just to demonstrate the column renaming, not because I actually care the name of this column. What happens there is we've made this change, but we haven't assigned it to anything. So that's actually like, it shows you that it would output a data frame that has a slightly different definition schema to it. I'd really need to do something like temp df equals that. And then we're actually going to set a new data frame. It shows me the schema of that in a little bit different way. Again, I can do a display around this thing and make use of it. So keep in mind, as we're doing data frame methods, it's going to return a new data frame. Sometimes it's going to return something different, but often it's going to return a new data frame for me to work with. So I need to set a variable on this side. So that's with column renamed. Pretty simple, not as often used. Used a little bit more often is with column. So here on this cell, we're going to import some PySpark SQL functions. So this is a good example of how we can do imports within Python. We need to know where these come from, in this case, PySpark.SQL.functions. And then we can import individual items, or a way you may do it, especially when you get started, is import everything from PySpark SQL functions. Okay. You may see a few other ways we do that before we're done, but in this case, I just imported what I care about. And when I add a new one, I'll go and add it up here as well. Okay, so what we do is we're going to set a brand new data frame called tripdf. To do that, we're going to call trip input df and a few with column statements that are composed one after the other by calling dot with column, specify the parameters, then dot with column. We're putting together several statements into one statement in our code. First, we're going to set a year month field by doing a substring, which takes a column name first, in this case our pickup date time, a starting and an ending position, and we're going to take just the first 7 characters here. Then we're going to replace all of the dashes with underscores so that I can create this year month field that I'm most likely to partition on going forward at some point. I'm also going to take dates and convert those. So I have this toDate function. Again, I pass a column name next. And then I pass a date format. So the date format is specific to Spark. It's not the same as a Python date format. So you want to consult the Spark documentation to look for other options beyond this year, month, day, hour, minute, second setup that I've used. All right. So we set a few dates using this toDate statement. And then we do with column, and we specify two different columns that we want to do some math with. So in order to say that I'm not trying to deal with a string called tip amount, I'm actually trying to read a column called tip amount, I use the COL syntax. So column tip amount divide by column total amount. And that's going to give me like my percentage that the tip was of the total amount. So when we run that, we get a new data frame called tripdf that I haven't bothered to display here. We'll work with it very soon. Another way to define the column names would be to do trip input df, so the data frame name that it's currently in, and then use square brackets around it. And that's another way to do that that's going to look probably a little more similar to what you used to in pandas, though it tends to be a little bit different still. So that's a way you can do it as well. I like to use this call syntax whenever it works okay. You'll see as we get into joins that it doesn't always work as well there. All right, so when I run this, I've created my data frame. I can always display that thing. I said we'd see it soon, but let's go ahead and take a look at what we just did. Sorry, we got to get the name right. Okay, let's go ahead and display that data frame. And now we can scroll through and see probably at the end that we've got some new columns here. Okay. Okay, the other thing I want to show is that we can read additional data frames and then do joins on them. Right now I'm reading another CSV, so this statement should look really similar. I'm going to read in some taxi zone data. I'm going to let it infer the schema since I'm not specifying it myself, and I'm going to do a show so we can just get a quick glimpse. So we have this location ID that we can use in a join, and then we've got some information about the location itself. Okay, let's take a look at a join here. So I'm going to create a new data frame called full-df. I'm going to create it by taking the tripdf data frame and then doing .join to zonedf. ZoneDF is the data frame I just created, which has my location ID and then some descriptive information. For that join, the next item in the join clause is going to be specifying the join condition. And so I'm going to say my tripdf data frame has a column called pu location ID, and that needs to be equal to zonedf.location ID in order for there to be a match. Just in case some of these zones don't exist in my zone data frame, I can set this as a left join rather than an inner join. The left join is simply saying that if the data exists in the first data frame, tripdf, but not in the second data frame, zonedf, go ahead and keep the value from the first data frame even though there's not a match. Okay, if I wanted to make sure it's not doing that, I could, and it's only going to keep matches, I could do inner join, or you can just leave that blank and not specify. Okay, and then finally, because I'm going to have two fields around location ID, I'm going to go ahead and drop location ID after I've done the join, so I don't have overlapping fields. So now we have our join, and we can do something with it, such as write the data. This is one common example of writing. If you're doing this locally or possibly in other environments that don't have the Delta libraries already configured for you, you may use a different format like Parquet. But if you're in Databricks or most Spark environments these days, you can run data frame name.write, and then from there we need to pick a format. I've done format Delta. Then we can choose whether we want to append or overwrite the data set. I'm going to do mode of overwrite so that every time I run this, it does a full reload of this data. Because remember, I specified a single month here. This isn't meant to be an incremental job at this point. It's meant to be take a single month of data, process it, and save it into a destination. Finally, I need to call save. And within that save statement, I give it a path to a location. I think no matter what environment you're in, it'll probably let you do /temp and then specify your path, and it'll create all that for you when it's Apache Spark running it. However, you may not have permissions to /temp depending on where you're running at. So you can always change that to whatever you need it to be. So this is a made up path that I want to save my data to. We're working with a limit here. I've limited it to 1,000, which I forgot to call out as we went through it. So it's actually going to be pretty quick. There we go. We've got our results. If I want to go see what the Spark cluster did more in depth, I can click on view down at this level and start to see all the different tasks that happen to make this run, potentially distributed across a cluster, though in my case, it's really just trying to run things in parallel on a single node because I've got a small single node cluster here. And we've done our first Spark application. Another way we could save it, just so that you see that easily, is again, call dataframe.write, choose a mode of override or append, and do save as table, which is going to actually register it with whatever Metastore catalog is configured in your environment. So let's see, this will work fine on Databricks. I think even locally, it's going to be able to save this to your Metastore as long as you haven't configured your environment differently than most default environments will be. So now I can go and select from that table if I want to. By the way, to pull back from that table, that's one way to do it. I've got that data. Another way is I can do spark.read table. There you go. That's another way to do it as well. So now once we have a table, there's a little bit more opportunity to read that data. We don't have to specify a full path like we would with the first state that I did. All right, that is our PySpark application if you're running it from a notebook like Databricks. Let's talk about if you're going to run this from a local environment. So in my case, what I've done is I have Windows, but I'm running Windows subsystem for Linux. So I'm running Linux within my Windows environment. So if you're running Linux, if you're running on Mac OS, these commands should work about the same for you. I haven't tested this on Mac yet though. If I want to download this data, I can use bash commands to get it from that site that I showed you earlier. So I can click here and go do it at the site myself, or I can copy this code. And as long as you have enough permissions in your environment, it will create a directory for the taxi zone data, go to that directory, and then get the data from the web address. If this address doesn't work, if it doesn't find anything, go to the website and find the new link you get when you go and try and click on the taxi zone data. Then I'm going to rename it just so it matches my other code that I already did. And then a very similar pattern for the yellow trips data. I'm just getting one single Parquet file. So instead of CSV for the yellow trip data, we'll get Parquet because that's what they now host the data as on the New York City taxi site. All right, let's take a look at this and then we'll go run just a couple of commands that are different. And then the rest of the concepts we already showed will apply to running this locally. Okay, so I'm here in a terminal session. Remember, this is Windows subsystem for Linux, so it's going to look a lot like Linux, a bit like running on Mac. I've got a virtual environment called PySpark that's activated, which basically means I can do installs and things here without impacting the rest of my environments. So if you don't have PySpark yet, you can do pip install PySpark and run that, and it'll get installed. Once you do that, the next thing you'll probably want to do, if you just did that, restart your session, come back in, activate whatever virtual environment you did it in. Once it's installed, we can call PySpark and it'll go and access the Spark shell. If you don't see this, if this doesn't work immediately, you may need to go in and find your site packages where PySpark is and look for this actual command that does this. The other thing you'll note when you first do this is that you'll need Java installed. And so you want to go get Java installed on your machine and set Java home to point to that path. Okay. If there's a lot of people having trouble with this, I can always come back and point to some resources there. But this is just special case if you're first setting up this environment. All right, so now let's get to the good stuff. I just showed that we can download some files. So let's do that before we get too much further. And so I had a few bash commands that I've copied. I'm going to go and paste those and run them. And what that did is it created directories if needed and then copied data into those directories. Let me make sure I run that last command. Okay, so it's a little bit of data. If you're on a very slow internet connection, give yourself some time, of course. But this is what we need to do to get started. Okay, once we've downloaded the data, we can go and run with the Parquet format, read in that yellow table. So we've switched our format here from CSV to whatever is specified in the trip format variable, in this case Parquet, and we don't need the header option anymore. Okay, we can run this and paste that data, show our data frame. Okay, so that succeeded for me. If your data made it to the right spot, it should succeed for you as well. Now we can create our zone data frame. Here it's still a CSV. The only difference is that I've tweaked my path just a little bit for where I put the data locally. There we go, zone data frames created. Now this code has not changed at all, except I think I added a display earlier. There's no display on this one because we can't run display locally. That's a Databricks and Synapse command, not a open source Spark command. Here we go. We've done our transformations, though remember it's lazy evaluating. I didn't do a show, so it actually didn't do anything. But it's ready. It's set up to do those transformations when we need to. Next, we define the join condition. This again is the same as it was in the first example where I did this in the notebook. Then finally, we're going to go ahead and save. In this case, we'll save to temp data set, so slightly different. Save it as Parquet just because you need to do something else special to get Delta turned on in PySpark at this point. I'll try to post a link to how to do that soon as well. But for Parquet, that's built in, ready to go. Here we go. From there, we've now got data saved. We could even then go confirm that, I suppose. Depending on your environment, if you're not running locally, this /temp might go to a different spot than you would expect. But if you're local, you should be able to just list that out and see it probably created one Parquet file unless you've got some sort of parallelization turned on. All right, with that, we've walked through the example locally as well. Hopefully you've been able to adapt this to your environment. Feel free to leave comments if you'd like to see it in a different type of environment. If I get enough of the same, I'll try and post those videos, but hopefully this is a good start to help you figure out how to run PySpark in your own environment. All right, there we go. Thank you for joining me for another Apache Spark Data Kickstart episode. Please like and subscribe so that you know when the next ones are coming out. Take a look at the description where I'll have some different links for places to learn more about Python, other videos that are similar, maybe using things other than PySpark. So I look forward to continuing this journey with you. See you next time.